After doing the first run of the PMG coupled directly with the engine, I discovered that I was going to need a way to step down the speed and also introduce a flywheel mechanism to provide a smooth running of the generator at a load. I decided to create a flywheel using a steel reinforced cement. I started off with a 3-inch steel pipe with 8 spokes. I then added 4 layers of heavy gauge wire mesh, which I cut off to the shape of the circular flywheel, leaving some allowance at the outer edge to ensure that the cement will cover the reinforcement fully when poured. I then placed a polythene sheet on the wooden board and added a strand of plain iron sheet all around the board. I had cut off the plain sheet strand to a thickness of or a width of 10 centimeters, and the boat took 1 centimeter, so that meant that I was left with 9 centimeters for pouring cement. I used screws, that was 1-inch gypsum screws, to fasten the plain sheet to the board, and I ensured that the sheet was flush with the board to make sure that I would have a good clean finish and an even distribution of the cement. So I didn't have a plain sheet long enough to do one round, so I had to cut it multiple pieces and put them together to complete the whole circle using a pair of scissors. So after cutting it, of course, I made sure that it was a uniform thickness of 10 centimeters, and then I fastened it all around the board using screws. I then brought out a belt. So for this case, it was easy because the length of the belt was a perfect match for the perimeter of the circle for the board. So the plan was to have a flywheel with multiple diameters. So, but for this case, I did not need to cut the belt because it was a perfect match for the perimeter. So I measured the thickness of the belt and placed it in the internal perimeter of the sheet to make sure that when the cement is poured, I was going to get left with a groove that is exactly the size of the belt, since my plan was to have the flywheel also act as a pulley so that I would have the belt running all through the flywheel. So once that was done, that was for the first part of the flywheel. I had already done the other one, but in this case, I could not get a perfect fit for the belt, so I had to cut it. And I also put some polythene on this half of the flywheel as well. And then I was planning of having a third layer that was going to have 3 valleys for the belt, and so I was going to put 3 belts inside, and that would match the pulley that I currently have for the PMG. And after all that, everything was all set. So I put back the external parts of the board from where I had cut the circles, and this was to ensure that the sheet followed like the perfect shape for the circle. Because without that, it was hard to get it to follow the shape. So this is the final finished mesh for the reinforcement. As you can see, there are 8 spokes in the rebar, and there are a lot of layers of wire mesh and other stuff. So I used pure Portland cement for the pour. So the whole process is you add water to the bucket and then you add the cement until you get a thick paste that is pourable. So the good thing with this type of setup is, even though it might look like it's very dilute, the cement, since it's not mixed with sand, is going to push majority of the water out. So it will only be left with the amount of water that I could use. And then we are having some. So this is the dried uh, slab. I had left it there for about 14 days, and I always made sure that it was underwater all through. So I removed the first layer, that is the smallest part of the flywheel that had the three grooves for the belts to match the pulley that I had for the PMG. So for this part, I had to cut off that part of the iron sheet that I was using for this layer, because the board of the top was too big for me to cut. I didn't want to cut. I did not want to cut through all of it at this stage. I just wanted to check to make sure that it was properly dried and that I had the grooving from the belts happening as I had planned or as I was anticipating. So as you can see, I had to pull it using my pliers because I'm actually tearing it off. There's a bit of it that was under the board, fastened with screws. So I just had to sacrifice the sheet and get it out forcibly. But as you can see, the belts, the three belts in the valley were set correctly, and when you put them out, the grooves were pretty good. There was only some minor issues at the joints because there was a part that had been cut, but those were easy to fix with a small scratching. So there were three levels of this. So I removed all the three, and out of these, I got the three grooves that were going to be used for the three belts that are going to run the PMG. So after that, I removed the boards and the coverings from the other two parts of the flywheel with different diameters. Made sure that I removed all the screws because otherwise the boards won't budge. But once these were removed, the boards came out very easily. So I did that for the upper part, and this was now for the lower part. And I think at this point you can see the three levels that we have for the flywheel. There's the biggest diameter, the outer diameter, then there's an intermediary one, and then there's the smallest one. Give it a little sweep because I'll be creating a stand for the flywheel with some bearings, and I'm going to upload that video later, so please like and subscribe so that you can get notified when that video is uploaded.